Good day, my viewers. You are welcome to another episode of Alternative to Chemistry Practical. Today, we still want to consider question number 3 of Alternative to Chemistry Practical, and these are the questions we are going to consider today. Now, read with me. A compound G on eating gives a crackling sound. Now, it gives a crackling sound. 1. Reddish brown fumes H. It gives a particular gas, and we describe that gas to be a reddish brown fumes, and that gas is represented with this letter H. Another gas J, which will light a glowing splint and a residue K. Okay, more knowledge about the residue now. The residue K is reddish brown when hot and yellow when cold. Then the question is asking us to identify J, that is, which compound is that? H, which gas is reddish brown? J, which gas relight a glowing splint? And K, what is the residue of that compound? Now note there is something. Actually, this question is asking us about triazonitrate 5 salt, and virtually all triazonitrate 5 salt decomposes. So here, this compound, the compound G, is lead nitrate, that is lead triazonitrate 5. This compound PbNO3 is lead 2 triazonitrate 5. How did I know? Now, like I said initially, that all triazonitrate 5 salt decomposes because of the description of the compound. A crackling sound, a reddish brown fumes. There is only one gas that gives a reddish brown gas. Even because of this reddish brown fumes of H, make me to know that it's triazonitrate 5. Triazonitrate 5 ions must be there, because it is only NO3 that can liberate a particular gas, which is a NO2. You can get NO2 from NO3, just the same way you can get CO2 from what? From CO3. And this NO2 nitrogen 4 oxide is called a brownish gas. The color of that gas is brown. Out of all the gases that we have, is only one that is brownish. The color of NO2, the color of this gas is brown, and that makes me to quickly think fast and say that the salt is PbNO3. Now, if we decompose PbNO3, let's decompose it, even though the question is not asking us to decompose it. But if we decompose this, it's going to give us PbO, which is lead 2 oxide, plus NO2, which is nitrogen 4 oxide, and that's the brown gas, then plus oxygen. Actually, metals that are moderately reactive, that they are not that much reactive, undergo this kind of process. So now our G is lead 2 triazonitrate 5, which is this one. Then our H is this brownish gas. Our H is NO2, which is nitrogen 4 oxide. So our H is nitrogen 4 oxide because of the description, reddish brown fumes, because of the description. Okay, then our J, that's another gas. A gas J which relight a glowing splint. One of the chemical properties of oxygen, chemical test for oxygen, is that it rekindles a glowing splint, though it has a similar property with dinitrogen 1 oxide. Do you get it now? But his own is unique. His own is unique because in this equation we can get dinitrogen 1 oxide. So our gas J is oxygen because the one that can rekindle a glowing splint. So our J is what? Is oxygen. And lastly, our K, the residue K is what? Is a reddish brown when hot, and then yellow when cold, and that cannot be any other compound. Our K is what? Is lead-2 oxide. That is our K. Another compound that is similar to that, this PbNO3, another compound, though the question is not asking about that one, but we can replace this PbNO3 with zinc NO3. We can replace PbNO3 because we are going to have similar equation the way we have it up here. Are you following now? We are going to have similar equation like this. So we are going to be having we are going to have ZNO plus NO2 then plus O2. But in this case, this one is not reddish brown. This one will be white. Zinc oxide will be white when cold and yellow when hot. So this zinc oxide is yellow when hot and white when cold. But for PbO, his own is reddish brown when hot and yellow when cold. Now the last question there before we call it a day. What is name given to the crackling sound? The name is called decrepitation. That's the name given to this crackling sound. Note that it is called decrepitation. Thank you for watching.